LCR meter is an instrument used to measure inductance L, capacitance C, and resistance R, as the name indicates. They can measure the impedance to a sinusoidal waveform of definite frequency and convert the measured value to capacitance or inductance. Higher-end machines can measure true inductance or capacitance, equivalent series resistance of capacitors, and Q factor of inductors. As actual capacitors and inductors are not ideal devices with only either capacitive or inductive components, they have a resistance in series, which is defined as the equivalent series resistance. It is often taken as a resistance to alternating current measured at a specified frequency, which could be the self-resonant frequency, or 100 kHz for switched mode power supply SMPS components and 120 Hz for linear power supply components. Q factor or quality factor is the ratio of a resonator's center frequency to its bandwidth when subject to an oscillating driving force. It is a dimensionless parameter which describes how underdamped an oscillator or resonator is. Another definition is the ratio of initial energy stored in the resonator to the energy lost in 1 radian of the cycle of oscillation. Obviously, higher Q indicates a lower rate of energy loss and the oscillations die out more slowly. The LCR meter measures the voltage across the device under test as well as the current through it. From the ratio of these two, it can determine the magnitude of the impedance. Higher-end devices also measure the phase angle phi between the voltage and current. In an inductor, voltage leads the current by 90 degrees, while in a capacitor, the voltage lags the current by 90 degrees. None of the devices have only one component for the impedance. Even resistors have some inductance, more so for wire-wound resistors. Benchtop LCR meters may have selectable test frequencies of more than 100 kHz described previously, with high-end devices operating even up to 3 GHz.